it's going to be ide. So what is it if it's, so here we have diphosphorus pentoxide. Di is 2, pent is 5. Diphosphorus pentoxide. And you know this, we know that this is going to be using this nomenclature method because these are non-metals. Phosphorus, oxide, they're both over there on the non-metal side. Over here, iron and chloride, that's a metal and a non-metal. We go over here to our acids, some of my favorites. Hydrogen and 1 or more non-metals. So hydrogen, 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 and then all of these are non-metals, right? There's not going to be no sodium in here. That's how we know it's an acid. Hydrogen plus a non-metal. So binary acids, we got 2 elements here, hydrogen and chlorine. Hydro, because of the acid, because an acid is always in an aqueous solution, so it's always assumed to be hydro, right? Base name of the metal plus ic. So hydrochloride becomes hydrochloric. And then you add acid, hydrochloric acid. Over here we got oxyacids. These are the ones that have hydrogen, and they also have an oxygen. So we have phosphoric acid here, 3 hydrogens, 1 phosphorus, and 4 oxygen. This is going to be an 8. 8, yep. Base name of the oxyanion, so that's the phosphoric right here. It's phosphorate. Now because it's being put in an acid, it's phosphoric acid. Make sense? Over here, this one starts with ite. So base name of the oxyanion, which here we have sulfur trioxide. So this would be sulfur oxide. And now it's sulfurous acid, because that's just how this naming convention goes. This is complicated, but it is useful to us, especially when we have labels on all of the shit that's downrange. Now you guys can have a better understanding of what we're dealing with, you know, how it breaks down. If all of a sudden, here we're dealing with nonmetals, which means we're probably dealing with what type of bond?
Covalent.
Covalent bonds, exactly, which means it's going to have lower melting points, lower boiling points, and that's what we'll be dealing with. If it's over here and you get iodide, or you start hearing numbers, right? Then we know that we're dealing with most likely an ionic bond, which is most likely going to have higher boiling points, higher melting points. And so it just helps us really with decon considerations, right? If we know how the chemicals behave, if we know what happens to them, we can then plan better. And you guys on the line can make decisions without needing the CP, right? Remember, what's my goal with this platoon?
Teach your opinion.
Exactly, I want to make y'all better than me. That's the goal. Part of that is chemistry understanding. Take a picture of this. In my more thorough class, I break down what each of these are and what processes they're most likely to be used in.
I never got the 22. I never understood why I used it.
Yeah. Kleisen flask, I haven't used that, so I couldn't tell you, man. I haven't seen it either in a lab.
It brings up the precipitation, and it's supposed to be like a changing chemical or whatever.
So we got our test tube number 1. Number 2, that's the boiling tube, so it's a little bit thicker. It's got a higher resistant glass in it. Number 3, that's your beaker. Very important. 4, we got our Erlenmeyer flask. So the difference between a beaker and a flask is the flask comes up to a point. Remember that by flask you can drink from. You're not going to want to drink from a beaker, right? Flasks you can drink from.
I drink from mason jars.
I'm sure you do. Okay, so a beaker is a mason jar. There you go. All right, 5, volumetric flask. It's got a much wider bottom, and it's how you can measure the volume of things a little bit more accurately. 6, round bottom flask. We'll use those a lot. 7, Florence flask. Don't worry about that. 8, what the fuck is that? Gildal flask. I don't know. That sounds Russian.
Then we might see it then.
Yeah, might. 9 is a pear-shaped flask. 10 is a retort flask. 11, 12, and 13 and 14 are ones you should pay more attention to. Schlenk flask, Strauss flask, Buchner flask, and separating funnel. I'm not going to need you guys to call up the names of the stuff, by like that close, but if it's a flask, if it's a round bottom, those are kind of important details to know. If it's a separation funnel, definitely gonna need to know that. You know, the big thing is the overall process. We're gonna need to know at the CP if what we're dealing with is distillation, or if it's something else, or what they're trying to do, right? And just going over these glassware and its uses is just gonna help you guys with doing that. So 14 is a separating funnel, 15 is a dropping funnel. Y'all know the difference?
Say it again.
14 is a separating funnel, and 15 is a dropping funnel. Do y'all know the difference?
One combines them with
One separates one.
Yeah. When you see this one, there's gonna be 2 different, or possibly 3 different liquids in there with different, what's it called?
Volumes.
Not volumes, different densities and weights, right? So the more dense liquid is gonna come to the bottom with the less dense liquid rising to the top, and you're trying to isolate that more dense liquid. And that's what this one is gonna be used for. Whereas this one is just adding stuff to a chemical process at a very, very slow drip. That's what this is for. It's called a stopcock.
And if you use 14, it's like how you would make something like, I guess it separates it, so it would be like something that's not currently hazardous, but you're separating and making it more into like a bomb or something like that.
It could be, depending on the chemical process, but that could absolutely be what it's used for. 16, funnel, 17, funnel, 18, condenser. So these are all condensers down here, right? All the way up to this one. These 3, they're all condensers, which means that there's gonna be water flow. Water's gonna go in on one of these and it's gonna come out on the other. And what that does is it helps cool it off, and so that condensation will happen within the system. For whatever chemical process that may be, it's very important in sarin. 21, we got a distilling column for all you fucking moonshine motherfuckers out there.
Don't wait till the room.
Yeah. And then the rest of that, you're not gonna really see much, but definitely go over these in your own time. Definitely learn them. Just because, like, we're CBRN, we're chemical, we're bio. We should know this shit.
What would you use 25 for?
25? I have no fucking idea.
That just looks like a useless thing.
I've never seen it, never used it. I ain't got a clue. But these are pretty much all the glassware that you can find in a lab. Types of agents we're going to go over, not necessarily in this order, because I did the slides wrong. I forgot the order I wanted to do them in. Yeah, I was a young E5. I was trying my best, all right? We got leukocytes, we got blood agents, we got choking agents, and then we're going to go into persistent and non-persistent, all right? Choking / pulmonary agents. What does pulmonary mean?
Lungs.
Lungs, exactly. So if it's a pulmonary agent, what's it going to attack?
The lungs.
It's going to attack the lungs. It's going to make your day very, very, very bad. So these are mostly heavy gases that cause fluid to build up in the lungs. It'll cause inflammation in your lung tissue, which is basically just aggravation, which can lead to damage. And then it can also cause pulmonary edema. Lack of oxygen causes death. If you don't have oxygen, you can't breathe, you die, right? If the brain is without oxygen for 8 minutes, you are brain dead, and that's that. Pulmonary edema, that is excess fluid in the lungs. It collects in the air sacs within the lungs. Heart problems are a natural cause, but also exposure to toxins, pneumonia, and trauma to the chest wall. And Anatomy and Physiology, chapter 22, page 1046 and 1047. Those are my sources, right? So the big thing where did I put it? It's over here. All right. I'm not an artist, right? That don't look right. Ah. Let's just go with the lungs. All right. Branch it off down here, branch it off down here. Each lung has 3 lobes. One lung is larger than the other lung. Why? Why is one of your lungs bigger than your other lung?
Because your heart's fine.
Because your heart's in the way of the other one, so that lung has to be smaller. Now, inside of each of your lungs, you got all these little branches going down throughout the whole thing, which are each filled with little air sacs, okay? What happens with pulmonary edema is these sacs fill with fluid. And when they fill with fluid, there's not supposed to be fluid in your lungs. It's not good. It's for oxygen only. When they fill with fluid, they cause damage to the surrounding tissue, which can then cause the lungs to fail. If enough fluid gets built up in here, that's less room for air. Air can't get in here, now you die. Dry land drowning. Make sense, everybody? Cool, I like it. That's the big hazard with choking agents, because they're heavy. A lot of them you can see, but a lot of them you can't until you all of a sudden you just start having trouble breathing, and then you die. Wrong one. Chlorine, my favorite one, because it's really easy to make. Right? It's a yellow greenish gas that causes lungs to fill with fluid, causes victim to drown. Yeah, it's a really big hazard for young people and elderly people, and that's because young people, their lungs aren't as fully developed and mature. So what happens then is it's a lot quicker for them to die. Old people, especially old smokers, their lungs are already scarred and damaged from life. So it's gonna be a lot quicker for them to die. Make sense?
Another word.
Scarred?
No,
Another word for what?
what was it you call it? Your the thing that fights against like bacteria and stuff in your body. Your immune system is not strong because you're older than younger still.
Well, that's true too, but your immune system doesn't do shit with chlorine. But that's also true. Gas irritates the mucous membrane. Liquid burns skin tissue. It only takes 1,000 parts per million to kill a person. And when it was first used as Ypres by the Germans in World War I, it's estimated that 1,100 people were killed in one day by chlorine gas. Now pay attention to that fourth bullet. Liquid burns skin tissue. Just because it's chlorine doesn't mean you have to only worry about one thing. Because if that liquid gets on you, it can also cause skin tissue damage, right? And then the gas is the big problem, but it will liquefy at certain pressures and temperatures, and it's carried around as a liquid.
It's more like a burn, more like for blisters.
It's a burn. It's a burn for this one. It's not a blister. Precursors for chlorine. Number one, chlorine pressurized gas bottles. Right? Chlorine is used in so many industrial processes in the industrial world at large. It's ridiculous. There's no way to effectively track chlorine that can be used as a chemical warfare agent. That's why it's very readily used. That's why back in Syria they use it a lot, because there's a lot of industrial uses for it, and it's easy to transport because everybody needs it.
You knew where you would make this if I was making a water park.
You're making a water park?
You just gotta bleach and you can get all other stuff without anybody noticing.
Well,
Exactly.
you have chlorine tablets if you have a large scale water park.
You'll have a lot of
one.
chlorine tablets.
Yeah.
It probably won't even be tablets at that point. It'll be actually like chlorine.
Yeah.
Because they need to effectively clean that water.
So I know they
Bleach.
sell it in drums, like Slitterbond and shit like that.
Bleach plus ammonia gives you chloramine gas, which does the same thing as chlorine gas. That's why you do not mix your household cleaners, okay? Yes, the shit that you get from Home Depot can effectively be used to make chloramine gas, which can kill you if exposed to it for long enough.
I just don't want bleach.
So we had to put signs up at my old job because this girl went back there, mixed all the cleaning chemicals together.
Oh, wow.
We had vinegar, we had bleach,
That's why
all
I need
that back there.
Holy shit.
She dumped literally every single thing into the mop bucket that we had back there.
Yeah, that's...
Reaction does not.
And she came up front and asked me why she was dizzy, and I was like, what are you doing back there? She's like, I was mopping. I was like, what did you put in the mop? And she said, oh, I put everything on the shelf back there.
That's
Some people should not breed.
I'm like, you
Right.
came here, killed yourself.
But bleach, don't mix shit with bleach. Don't drink bleach, all right? Bleach makes shit bad. Makes shit clean, just don't mix it with shit. All right, now we're gonna go into phosgene. I kind of like this one. Phosgene is a colorless gas. It smells like newly mowed hay. Not that I know what that smells like. I am not a country boy, all right?
Awesome. It smells like a glorious day.
It smells like a glorious day.
Happy over it.
So if all of a sudden Sweat gets really happy, we know there's phosgene around.
Yeah.
All right, phosgene is much more efficient at choking the victim than chlorine, because chlorine naturally occurring. Phosgene is not. It is an actually developed warfare agent. It can either be a non-flammable gas or a refrigerated liquid, depending on who's making it. Symptoms show 24 to 72 hours after exposure. So you get exposed, you get hit with it. Next couple of days, all of a sudden you're dead. Blood loss, shock, respiratory failure. Your lungs fill with fluid and kills the victim. Why do the lungs fill with fluid? Because it's a what agent?
Choking.
It's a choking agent. There's your formulas. These are the two that are recognized by the Chemical Weapons Convention, the CWC. Carbon, chloride, oxygen, carbon, oxygen, chloride. You see?
It's like Coca-Cola.
I know, right? But you see how it's the exact same shit, but just structured differently? That's what I was talking about when these scientists and these chemists out there can continue to make chemical weapons that don't violate the Chemical Weapons Convention because lawyers wrote the Chemical Weapons Convention. They used the two formulas that were out there with phosgene, and these are what's recognized as phosgene.
As long as it don't look the same, it's fine.
Yeah. All right. Lethal. 25 parts per million in 30 to 60 minutes. 50 parts per million in short exposure. So if you're only exposed for a short time, you need more of it to kill you. But over a longer period, it can just be sitting around. And since it's odorless, and I don't know what newly mowed hay smells like, I'd probably die. What was our parts per million for chlorine?
1,000.
1,000 parts per million in chlorine. So it's much more efficient. It's much more gooder. Oh, I legit wrote, I don't know what newly mowed hay smells like, but it similar smells grass. Ask the country boys in the class. There you go, Sweat. All right, if on a site and suspect phosgene, look for refrigeration units. They're gonna have to have them to keep that phosgene nice and cool so it doesn't start off-gassing and kill the workers. Fucking hell. In World War I, this agent was responsible for 85% of the 100,000 chemical agent deaths. That's big numbers. Does have various civilian applications in manufacture of chemicals, pharmaceuticals, and pesticides. Of course it's a pesticide. It's a fucking chemical warfare agent. Avoid contact with water and aluminum. Application of water can cause phosgene to break down into corrosive hydrogen chloride, which is corrosive. Obviously.
You used to actually try to get this off with water and it just probably made it worse.
Yeah, because that just spread it. That just caused. All of a sudden, that caused. Where was it? Oh, it's not. It's on my next slide. But that caused chemical burns. So that's why I wanted to really go over this class, because now I've said it so many times, right? We can't use water on everything. Now I have an example. Don't use water with phosgene. It can cause what?
Chemical burn.
Exactly. Because of what? Hydrogen chloride. Phosgene decon. Water. This is from the CDC. Phosgene is unlikely to contaminate water because it breaks down rapidly upon contact with water to produce hydrochloric acid and carbon dioxide. Potential for chemical burns. Now, the CDC does recommend to use water and soap with it. No, we're not going to do that. If there's a potential for causing chemical burns, we're not doing that shit. Right? Dry decon preferred. M100s, M295s, that kind of shit.
Most likely lose your sight.
Yeah.
NIOSH says dry only. Don't use water.
Mm-hmm.
I said, well, I don't think
That
they
makes
have
sense,
to do it
soldiers.
themselves.
What's up?
I said they can do it out there and do it themselves.
Yeah, see, if the CDC wants to use water and soap on phosgene, they are more than welcome to. The CBRN platoon will not be doing that.
I was driving down the highway one day and I kind of have a problem. Whenever I see a placard truck or a train car, I go looking at the EGR on my phone. and see
ERG.
what it is.
Yeah, I used to do that too.
And I found a truck with phosgene before.
Yeah, see, it's out there.
It's out there.
It's just out there.
I think of that train that had, it was like a movie they
Mhm.
So carbon, 2 chlorine, and an oxygen, right? Carbon, chlorine, oxygen, hydrochloric acid, carbon monoxide. Those are all potential precursors, right? Because carbon monoxide, what's that?
CO2.
Carbon monoxide.
Oh, carbon monoxide?
Yeah, carbon and oxygen, right? What do you need for this? Carbon, oxygen, and chlorine. So if you start seeing a bunch of carbon monoxide around, because that also has industrial purposes, just keep that in mind. Everybody good? Nope. So there was another agent back in World War I and World War II called diphosgene, right? So 2 phosgenes. However, its use was limited, but all the effects were similar to phosgene. It's just a different version. Always trying to make a better way of killing people, right?
That is what we're good at.
And,
It is. It's been about an
Aliens are
hour.
gonna show up and they're gonna be like, rules of war, what's that? I'm like, we'll show you.
We'll show you.
We'll
We're
show you why
experts
you
at
did
this.
it.
All right, it's been about an hour, so soldiers, go ahead, take 10 minutes. Be back in here at 10:43.